Uh-oh.
So going green with the Tech Junkies, we're trying to make some power get generated between wind turbines. We're going to cut some blades out of this PVC pipe, and we're also going to make some solar cell panels with some old windows we have. We'll start with the wind here. We've got two different motors we're going to try testing out. We got this one off eBay. There's quite a few available you can pick from. And this happens to be a 115 volt DC motor. You want a DC motor so when it spins we can actually pick that up right to our inverter without any added electronics. This one is 115 volt DC. This is a 24 volt DC motor. We're going to try two different sizes and see how it goes. And for our blades, we've been reading a lot about people making these really cheap blades out of PVC pipe. So we picked up this full length of 8-inch diameter PVC pipe. We're going to cut one set of blades out of this about 3.5 foot long piece, and with the rest of it we're going to make a bigger blade system once we can prove out that this system works and see if there's any flaws that we need to improve on first with the smaller system. And then we have an old tripod that we're going to use and see how high up we need to get. It also shows that the higher up you can get, the more sustained wind you can pick up. So we'll see and test it out at different heights, and that's that project. Oh, one last thing I want to mention on this is we found a calculation online. Somebody set up a nice website that you can put in all your values of what you want your turbine to do, and it'll tell you exactly. Actually, it prints you out an image that you wrap right on the pipe, and then you can cut out. It makes it really simple and really easy. So we're going to use that calculator online to get us pretty close to get started, and then we'll take it from there. On our solar project, we found these solar cells. They're 3-inch by 6-inch solar cells, and we found you can get some really cheap ones, pretty economically priced. They just either have a small crack in them or a small little gouge in it, but they're typically less than half the price, and they still work more than half as well. So we're going to use these. Again, it's just to get started, a homebrew, do-it-yourself. How can we generate power? So with these solar cells, they all have to be soldered together. And we've got some old windows. We're going to put 28 of these together in series. And we've got some tabbing wire. This is some neat stuff. It's a flat piece of copper with solder already on it. So all you have to do is take your flex pen, which is what this is. This is what makes the solder stick, per se, to the copper trace on here. So you just run this down here, and then your tabbing wire, which is pre-soldered, you just heat the soldering iron on there, go down there, and keep making a bunch together. And we'll show you some tips and tricks on how to make this easier. Because even with this small, modest 500 watt system, we've got about 300 of these little cells to solder together. Quite a lot. And once we're all done, each window is going to have, like I said, 28 of these on there, which will be a 14 volt system. We'll add a diode on there which will prevent power going back into the solar panels in case this one happens to be in shade and a different one happens to be in sun. It won't throw the power back to the solar panels. So we've got our diodes that we got to hook up. We've got a whole bunch of these solar cells, our tabbing wire, our flex pen, and we'll show you the windows here next and what we're going to put it together with. The reason we're able to keep this system cheap is we were able to find some old windows on the side of the road. Either people were throwing them away or from old construction jobs that they're just getting rid of. And this is free. The other idea we had was to look into, a guy has been making these aluminum L brackets that all fit together, and you buy a sheet of glass that sets in there. You start adding all that up, you're now over $1 a watt. So with this system, all we're going to do is we're going to lay the panels on here, solder them all together, and then you pour some epoxy on the back side of it to hold everything together and let the sun come from the other side. Ties everything together. It should be just as sturdy as anything else that's made, and much, much cheaper. So this is what we're trying to do, keep a low-cost, free energy system. I wanted to talk a little bit about the pricing of this stuff because I was very surprised at how cheap solar and wind energy can be, especially with rising energy costs from our power companies every year. The 600 watt grid tie inverter, very easy to use. Literally, you have your DC source in, which on this particular inverter can be 20 to 60 volts. And on the other side, you literally have a plug, just like your computer cord. Plugs in here, plugs into your wall. It will match the phase of the AC power coming in and actually generate a larger supply on this side of your meter. So that way, if you're generating more power than you're using, sometimes your power meter can actually run backwards. And that's a great thing, that's free energy. So these systems cost about 25 cents per watt. This particular one, last week we paid $138, including shipping for, and we actually got a 600 watt instead of the 500 watt. The guy was out of the 500, so he sent us a 600. The wind energy, the tube, this 8-inch diameter tube, was fairly expensive. It was $100, but if we're going to get 2 wind turbines out of it, that actually knocks the power down quite a bit, or the price down for the power. This motor, you can pick these up on average under $100 really easily. We got lucky with this one, found one for sale for $35 including shipping. This one came out of an old electric bike we had, an old little electric scooter. And so if you figure this thing can generate about 1,500 watts for $35, much cheaper. The solar cells themselves are also about 25 cents per watt. The reason we can get these cheaper like this, if you notice on here, it says less than 20%. And what that means, each one of these cells, even though they're 3x6 cells, some of them are broken a bit, and I mean, you're paying like half price, but it's still going to output just as good as the other ones. So if these are about 25 cents a watt, these are about 25 cents a watt, you're talking a total cost of about 50 cents per watt plus the time and labor to put this together. But to have a power generating source for 50 cents a watt, I think that's incredibly cheap. And if you do some rough calculations, we think we're going to be able to pay this system back in about 3 years. Again, there's a lot of time and work involved on your end putting it together. And if you had to hire some workers to do that for you, obviously your payback time will be longer, but for us, 3 years is a pretty big incentive to get this going. This is our first solar panel window we're going to create. I started laying these across here, and it looks like we're going to have about 28 full panels once we're done creating about 14 volts. A little less because of the diode that's going to be on there. We couldn't quite fit another full one to the left, and trying to make it go sideways is going to be really a pain to solder it together. So we opted to take our solar cells and break them in half so we could still have one solder line down, making it much simpler. So the next step is going to be putting these all together. Once they're soldered together, do a few basic electrical measurements, make sure we're good, and then we'll pour some epoxy on the back of this to lock everything in place, and our solar panel should be done.
First step in assembling your solar panels is to run your flux pen down the length of the shiny little wire on the top of the solar panel. And this is just going to make it a lot easier for your tabbing wire to stick to the panel. Once you've got that done, you're going to take your thinner piece of tabbing wire, and we found the best way to do this is just to anchor the tip of the tabbing wire to the top of the solar panel. And then once you've got that stuck there, it's a lot easier just to move your soldering iron along the tabbing wire, and it just ends up sticking down onto the entire panel as you see here. And this doesn't have to be perfect, but you just want to get a decent amount of it touching the wire so that you've got a nice amount of conductivity there. So it takes a little bit of practice to get this right, but that's why you have broken panels, and that's why you try it a few times before you're actually building your real panels. So we have both the tabbing wires laid down here now, and really it's just tons of this now. This is going to be what you spend most of your time on, as you can see here, just a little time lapse of putting together all these panels, because all of them have to overlap on one another. And we found just using these sockets and setting those on top of the panels hold them in place pretty well. And then you just want to stick a little bit of solder on the pads on the back of the panels, and then your panels just lay on top of each other like this, overlapping, and it basically puts all the solar panels in series with one another. So you just solder the tabbing wire onto the back, and just do this for as many panels as you have. We found the best way was just to hold it down with just a little metal pick or something like that, and then solder it with the soldering iron. Now at this point, the two panels are giving us about 1.13 volts. And now comes the fun of putting together all the panels. So you can see all of these rows are going to be connected in series, so we're getting about 15 volts in the end. So once you've got all of these laid out, you can see we left a bit of tabbing wire sticking off the end there, and we use the thicker tabbing wire now to actually link all of those panels in series. So those 3 rows are now 1 row, essentially. Then we put 1 wire on one end and another wire on the other end, and there's your complete series circuit. Now at this point, you're going to want to cover the panels with tape to kind of seal it off before we put the resin on. And this is just polyester Boaters resin that we ended up using. We used about 1/8 of a gallon for the entire back of the panel. We found that was a pretty good amount, so we just measured it out with 2 cups of, I don't know, standard coffee cup. And here's adding the hardener, and then stirring it up to start the chemical reaction. And then we just pour it on the back there. And you want to get a paintbrush or something you can use to kind of get all the resin all over the panel. And then just wait for it to harden, and you should have a complete panel good to go. And you're also going to want to make sure to add your blocking diode so that you don't have any issues with connecting multiple panels in series.
We've got our 8-inch diameter pipe here, and we're going to cut this into 6 blades. What we're going to do first is we're going to cut this thing into thirds. And then I've kind of drawn out here, it's not the right size, but we're going to have the blades taper down to a fine point at the tip and wide at the base. So that's going to be the next step that we have to do. Let's get this thing cut.
So here we are cutting the pipe into 3 different pieces. And of course we're going to get the six different blades out of this. So we just drew a diagonal line using a straight edge there, the tape measure here. And then we cut each of those pieces that we cut into thirds into halves. So there are 6 pieces, and you can see they're kind of shaped kind of funny. It's really interesting how you get that shape out of the pipe. And for this, we ended up just kind of coming up with a basic idea for what we want it to look like. After looking at all the calculations online, even if we had made this as efficient as possible, it would really only get us another 5 or 10% more power out of the blades. So we ended up just coming up with our own design here.
And I got your focal point. It's 2.5 inches to the focal point, 3 inches.
No.
Sorry, this way, right there, 3 inches focal point. It's 3.5, 2.5. Then 6 to the cutoff line, and 2.5 from inside here.
I guess that's kind of like our template then.
Yep.
Oh, they also said too that if we can taper this point, you'll get less noise. But I think with the low RPM, it won't fall apart or break. We made a total blade length of 43 inches because it sounded good.
At this point, we need to come up with a hub design that we could anchor all of the blades to. So I'm sure not all of you have CNC machines in your back room of your house, but we ended up just coming up with a quick design. You can buy existing hubs that people have designed and put up on eBay for fairly cheap, so that's another option for you. And then there we go. We had quite a bit of flex, which we were surprised by with the PVC. Here's getting all the different blades attached to our hub. And then here's heading out for the first wind test just to see if the wind wanted to spin it at all.
Oh God, it's out of control! So this is what we've got so far after assembling this together. The next step is we're going to take a hunk of aluminum to connect it to our hub here so we can actually spin the axle, which is going to turn the motor. And that's the next step. But as you can see, we've got this together now. We've got our 6 blades. Seems to have turned out pretty well, and hoping to get this done here soon because we've got some good wind out there. It'd be a good test.
So here's cutting out the hub. And there's the final hub design. So of course we stuck it on the end of a pipe to try it out first, and here's us walking outside for our first trial run. Trying to position it into the wind just to see if it'll spin it, and of course we got to spin, first try. And once we anchored it here, we got some pretty good results.
So to do this, we figure everybody should just go out back behind their house to their old junk pile, which is what we've done here. And we've got this old tripod. The thing's been sitting here probably 25 years. And basically it's just a pipe that is on a support system at the bottom, a few pieces of steel put together, and this will be a great test to get us started. This will hold our small blade design fairly close to the ground, but we got to start somewhere. And then if we need to go higher, we'll build some more pipes and maybe some guy wires if needed to support it. But yeah, this was some, I don't even remember what this was. Something to do with the old farm that was here. So we're going to pull this out and get this to work. 1, 2, 3.
And there's our tripod all rigged up to the tractor, bringing that out in front. And then just some quick sketching to try and figure out how we're actually going to mount this all together. Of course we had to have a nice spray paint coat on our blades, so of course the only colors we had were red and green, so it's kind of Christmas themed, but whatever, it works. And now we actually had to build something that the whole thing could pivot on. So this is just a snowmobile bearing, which we attached a rectangular tube to. And that tube is actually what the tail fin will get mounted to. Here I am cutting it out. Just a basic design, you know, kind of square with 2 little angled cutoffs, which seem to work pretty well. And there it is with the tail fin mounted on the tube, and then the motor is just getting screwed on there onto the other side of the plate, which swivels on that snowmobile bearing. So there's the whole assembly put together. And then of course the windmill. So we attach that to the end of the motor. And then here's our first trial run with the motor attached, which is pretty exciting. And here we go, bringing it up for the first time. And there it is. Of course, starts catching wind right away. Speeds right up, and looks like we're getting power output. And that brought day 2 to a conclusion. So first thing, day 3 is testing, and just finish up the last things we needed to do. So we just ended up getting a piece of PVC that we cut out that we could fit over the motor to protect it in the rain. So of course this is kind of temporary, so we're just latching on there with zip ties. Very...
We can't get out the door. Okay, I'm gonna go get a helmet.
Okay. I might want to get one too. But of course, nothing ever goes perfect, and... Uh-oh! Problem! The tripod tipped over. I don't know. Yes. That was not good. So we decided to recover from our damages and bring the turbine back in. So we just had our first failure. The wind gusted up and knocked down the tower, and now we've got a chipped blade here. But overall, that's all the damage we suffered, so not too bad. And here we go, our second trial run. Hopefully not going to end as, you know, badly as the first, but I mean, in all consideration, we really didn't get much damage. So of course, we were already talking about we need to gear this up more, but you can see it's just flying in the wind, and we were really only getting about 4.5 volts out of it, about 2 amps, so you know, only 8 or 9 watts, which is not much at all. But as you can see, it's spinning so easily that we could very easily gear it up and get much more power out of it. Of course, the next obvious question is, how do we stop it? So you can see having some trouble with the wind spinning the turbine back up. Ben finally got the 2x4 in there to stop it, and thankfully the PVC blades are pretty forgiving, so that finally let us get it down.
We've put the windmill up and taken it down. Turns out that the wind is quite strong today, and we need to do some changes before we put this thing back up. As we saw earlier, the wind came up so high it broke one of our blades here when it came crashing down to the ground. And we just wanted to show you a little bit about what we think we're going to do next, how to make this a little better, and come back later in a future episode and show you it installed and working. Some of the weak points we found on this is our pivot point. Tends to rock a bit on the top of the tower, and that's basically just because we bolted an old snowmobile idler wheel for a pivot point. And so we're going to change that around a little bit to be more sturdy. And obviously we have to take our wire and put it down in the middle of the tube before we're ready. Some things we noticed that this thing is spinning so fast, so easily, that there's hardly any load on the motor. We're only getting less than 10 watts out of this thing right now, so we can easily gear this up and pull more power out of the air. So the next thing we want to do is actually put our bigger blades on. Right now we've got a 7.5 foot diameter wind turbine, and we're going to take our other length of 8-inch PVC pipe, and when we cut that part apart, we're going to get a 12.5 foot diameter, which should get us plenty enough power to move this motor as fast as we need. So we're actually going to take some bicycle gears, which we have here, and figure out how to gear it up. We're probably going to use one of the big ones to the smallest one and gear this thing up quite a bit. And we hope that our 12.5 foot diameter will be able to turn that with enough torque. I think it will. So with a bigger blade design, a higher gear ratio for our motor, that should turn it quite a bit more, get us more power. And we just got to make this thing a little more stable, a little more secure, and we should be able to pull a lot more power out of the air and actually make it a realistic working wind turbine. The other project we had was our solar panel here. And this was our first attempt at ever making a solar panel. And I remember reading on a forum somewhere that some people had tried making their own solar panels and had a lot of problems with it. And one guy had responded, okay, now that you've gone through that nightmare, you can go back to just buying them, because it is a lot of work and there's a lot of things that can go wrong. And just looking at it at first, it looks really cheap and easy to do. And after enough practice, I imagine it would be easy to do and be a bit cheaper than buying them. But it is definitely a lot of work, and you're going to put some time in figuring out how to do it at first. So this was the first one we made. And really, it went together pretty easily with all of the soldering of the panels together. And that was pretty smooth. Put it into the window. The issue we had really was on the back side of it. When we poured our epoxy on, it was some older epoxy, and it needed some extra hardener because it was older, and it didn't actually quite set right. You can see it peeled up, and at first it had soaked into the masking tape and slid underneath between the solar panel and the glass, which is what you can see these bubbles are. We tested the solar panel out. We were expecting it to get a maximum output of about 50 watts. This one gets about 35 watts in maximum sunlight from what we found. So there is a few little things that we need to tweak here and there, but overall, I mean, it's definitely going to be a power generating panel. We have to build one more before we can hook it up to our grid tie inverter and actually create electricity back into our grid. But shouldn't take long. We've got enough to build 7 more panels. We're going to go for it, put it all together, and like I said, we'll come back in another episode and show you all of these things working and installed. So until next time, good luck with those projects.